Alright, so let's take a look at this problem. And again, we have the same directions. We're going to look and state use the rational um, root theorem to generate a list of possible rational zeros. So um, we want to look at the factors, and we love prime numbers when we see them because it makes a smaller list to check. The factors of 2, my constant term, are just 1 and 2. And the factors of my leading coefficient, because this is in standard form, it's just plus or minus 1. So the factors of the constant term become a numerator, and the factors of the leading coefficient a denominator. And we've been dividing by 1 so far in these problems, so you'll like that. Whenever this leading coefficient is 1, you know, we won't have fractions to worry about. And when this other constant is a prime number, the list is really short. That list of possible, and we do have to stress possible, rational roots. Now I could have put rational zeros, rational x-intercepts, because it means the same thing. That's where you just have to increase your vocabulary. So we've got plus or minus, and don't forget the plus or minus 1 and 2. Now, again, this is in standard form, but we're missing an x cubed, we're missing an x. The exponents are small enough and these numbers are small enough, it's probably just easiest to plug this in and see if we can find a 0 that way. If I plug in a 1, I see the x to the 4th is 1, and I see over here that I've got 1 plus 2, which is 3, and right here 1 squared is 1, so I've got 3 minus 3 right off the bat. I do see that 1. Now once I know it's a 0, I definitely do want to use the synthetic division. However, I just noticed something. I could go through all of this work of factoring it using synthetic division, or I could just look at it and say this is quadratic in form, where I know that this is going to factor to x squared minus 2 and x squared minus 1, because negative 2 times the negative 1 is positive 2, and negative 2 plus a negative 1 is negative 3. And then this x squared minus 1 is going to factor to x plus 1 and x minus 1. So I know that the negative 1 and positive 1 are going to give me zeros there, because I can see it through the factoring. Now suppose, what if you hadn't noticed that? What if you didn't know that we could right now jump to the answer and say x equals negative 1 and x equals positive 1? If you didn't notice that you could factor it, we'll still get the same answer. And it's not that much more work. We have a 0x cubed. We have a 0x, so we do have to put our missing terms, 4, 3, 2, 1 constant. I've got 1, 0, negative 3, 0, 2. And I know, I already plugged in 1, I know to expect a 0 here. Alright, now we look at this and we see that we have x minus 1, and this is 1x cubed plus 1x squared minus 2x minus 2. You may notice here that you can actually factor by grouping. You know, that we can make a table and enter our table left to right. And we can look horizontally here and say negative 2 is common to both. X squared is common to both. Here, an x to the first, and here just a 1. Okay, so let's shrink it. Well, shrink that up. See if I can select my box. Nope. Alright, well, it's not cooperating. Yeah. Alright, I'll just shrink it all up more. Alright. X minus 1, x squared minus 2, and x plus 1. X squared minus 2 is going to generate irrational. It wants just rational, so 1 and negative 1. Like I say, just for illustrative purposes, if I have x squared is equal to 2, then x is equal to, and these plus or minus irrational numbers. And it wanted rational zeros. So we found the list, and the list was short, and in that list, 1 and negative 1. Now, I noticed that I could factor with a table. If you had not noticed that, and you're looking at this and saying, how can I factor this if I don't notice? Well, you still have this rational root theorem. Remember that this list will only get shorter. It won't be added to it. And with a leading coefficient of 1 and negative 2, the factors of negative 2 are still the same factor. So we still have the same list. All right. And if we jump in and try a negative 1, and I'm cheating a little bit because I know I saw that negative 1 is going to work. 3, 2, 1 constant. So I have the x minus 1. Now because this is 0, I have x plus 1. This was x cubed, so this is x squared. And this is x squared 0x, so it's just x squared minus 2. Like I say, that's going to generate plus or minus radical 2. That's an irrational zeros. And we have 1 and negative 1 as our only rational zeros, our rational x-intercepts, our rational roots to this problem. So hey, I hope that helps, and I'll talk to you later.